in this series of lessons we're looking at various ways of producing salts. In this particular lesson we're going to look at how we can produce a salt by reacting an acid with a metal oxide. Okay, so let's just look at the general equation for this reaction. So we have an acid reacting with a metal oxide, and that will always produce a salt, that's what we're after, and water. So before we decide which acid and which metal oxide we're going to use, we have to think carefully about the salt that we want to obtain. So for example, suppose we want to obtain a sample of copper chloride, okay, which has a formula CuCl2. Well, as you know, the salt consists of a cation, which is the metal, and an anion, which in this case is the chloride anion. Then it will be the acid which provides the anion, in this case hydrochloric acid, and the metal oxide which will provide the cation, which will be in this case copper oxide. So let's just put an AQ there because it's an acid, it's an aqueous solution of an acid, and that's being mixed with a copper oxide to produce a solution of copper chloride, okay, and water. So what we want to obtain is a solid sample of copper chloride. So let's look at the full procedure to obtain this. So what we're going to do is start off by adding our copper oxide here to a solution of hydrochloric acid, dilute hydrochloric acid, and each time we add a measure of copper oxide we're going to stir the solution using a glass rod until the copper oxide fully dissolves and completely reacts with the hydrochloric acid. And you'll notice that as the aqueous copper chloride solution forms, that this becomes a light bluey green colour. But there will still be acid present in the solution, so what we want to do is we want to keep adding copper oxide and stirring, then adding more copper oxide and stirring until all of the hydrochloric acid has reacted with the copper oxide. So you want to keep on adding copper oxide until no more copper oxide dissolves, and when that happens you're going to get an undissolved residue of copper oxide at the bottom of the beaker. We then filter the mixture. So we're going to take this, pour it into the funnel with the filter paper present. Okay, so we're going to filter. The residue will remain in the filter paper, we don't want that, but what we do want is the filtrate, which is the aqueous copper chloride solution. Okay, so that should be pure copper chloride solution. We haven't quite finished because we want a solid sample of our copper chloride. So the next thing we're going to do is we're going to gently heat the filtrate. I should have mentioned that this is called the filtrate here, what you collect in the beaker after filtering. So we're going to gently heat the filtrate, which is copper chloride solution, until it just starts to boil, and then we'll remove the heat and slowly water will evaporate from the evaporation dish, and that will eventually leave a sample of solid copper chloride at the base of the evaporation dish. Okay, so following this procedure we've obtained a sample of copper 2 chloride, which is what we wanted, by mixing dilute hydrochloric acid with copper oxide. So supposing we wanted to obtain other salts, well, we've just looked at the procedure for copper chloride. So supposing you wanted magnesium nitrate, for example, well, you've got the nitrate anion, so we'll be using dilute nitric acid, and to that we'll be adding magnesium oxide. And to obtain calcium sulfate, we'll be using sulfuric acid. We'll get our sulfate ion from the sulfuric acid, and calcium from calcium oxide. So in the next lesson we'll look at how to produce a salt by adding a carbonate to an acid.